Okay, so now we are starting the topic total internal reflection. In short form, it is also known as TIR. Okay.
Okay.
For total internal reflection to take place, first of all, we have to consider these two conditions, that a light ray has to pass from denser to rarer medium. Okay. What does
Okay.
it mean? I'll tell you later on. And the second condition is angle of incidence must be greater than the critical angle. What is this angle? I'll tell you later on. First of all, for total internal reflection to take place, we are taking a semicircular glass block. To understand this thing, let me open my whiteboard first. Okay, as I told you that reflection take place in plane mirrors, right?
Yes.
But here we will be observing the phenomena of total internal reflection in glass block.
Okay.
I am taking a transparent semicircular glass block. Okay. This is the normal drawn on semicircular glass block. Okay.
Okay.
What will happen to this light ray when it is incident on the normal?
It will reflect back in the same place.
This is a transparent block.
Oh, it will go through in a straight line. It won't bend.
It will not bend. It will pass from the glass, right?
Yes.
Like this. Clear?
Yes.
Okay. Then, as I told you, for total internal reflection to take place, the first condition is we have to move from denser to rarer. That means we have to move the light ray from glass to air. So if I'm moving the light ray from glass to air, that means the ratio must be sine of angle R to the sine of angle I, right?
Yes.
You have to keep these things in mind, okay? Now, I am considering the light ray at an angle that is inside the medium, okay?
Okay.
Because we have to move from glass to air, isn't it?
Yes.
Okay. Now, at this particular point, this ray is acting as an which ray? Incident or refracted ray?
Incident.
Incident ray. Now, if this ray is acting as an incident ray and it is going from glass to air, what will happen to this ray when it is going outside the air?
It will bend away from the normal.
It will bend away from the normal like this. It's a normal phenomena. Clear?
Yes.
Any confusion up till here?
No.
Okay. Okay, the next thing. I am increasing the angle of incidence a little bit. Previously, it bent away from the normal like this. Okay, firstly, and then in the second condition, I am increasing the value of angle of incidence a little bit. Okay, what will happen to the ray of light? This ray of light, it will further bend away from the normal such that it will come at the surface of the glass block like this, isn't it?
Okay. Yes.
What is this angle?
45.
No, just tell me, what do you know? What do you call this angle?
Oh, this is angle of incidence.
Angle of incidence.
Yes.
What do you call this angle?
Angle of refraction.
Refraction. Okay. What is the value of angle of refraction over here?
0.
This is normal, and this angle of refraction is drawn with the normal, and this is the refracted ray.
90 degrees because it is perpendicular.
90 degree. So angle of refraction here is 90 degree. Okay.
Yes.
Now just put the value of angle of refraction over here and check it out what value you are getting in this particular formula. In your calculator, put sine 90 degree.
Okay.
Put sine 90 and check it out what value you are getting.
Sine 90.
What is the
1.
answer?
1.
That means value of angle of incidence at which the angle of refraction becomes 90 degree is known as critical angle. Did you understand?
Value of incident angle at
The
which
value of angle of incidence at which the angle of refraction becomes 90 degree is known as the critical angle. That value of angle of incidence, that means what value of angle of incidence I am setting, that at which this refracted ray comes at the surface of the semicircular glass block.
Okay.
Okay.
Yes.
So that value of angle of incidence is known as the critical angle. Clear?
Okay.
And it is denoted by C.
Okay.
This is the formula of critical angle and refractive index. Is that clear?
Okay. And
Any
so
confusion?
n equals to 1 over sine um
C.
sine C. This is for
Angle
finding the critical angle.
for critical angle, or conversely, if critical angle is given, you can find out the refractive index as well. Okay.
Okay. Okay.
So at first, you have placed the angle of incidence normally and you have observed the phenomena of angle of refraction. Okay. And then secondly, you have raised the angle of incidence such that the angle of refraction or the refracted ray comes at the surface of the semicircular block such that it is making an angle of 90 degree with the normal. That value of angle of incidence at which the angle of refraction becomes 90 degree is known as the critical angle. Clear?
Yes.
Any problem?
No.
Sure.
Yes.
Now in the third part, what I will do, I will further raise this value of angle of incidence, which is now the critical angle. Okay.
Okay.
I will further raise this angle such that this ray will bend inside the medium. Okay.
Okay.
So in the next drawing, what I will do, in the third part, what I will do, I will increase the angle of incidence such that its value becomes greater than the critical angle value. The value that I have set before, at which the angle of refraction was 90 degree. I am raising the value of angle of incidence from this value. Okay. What will happen now? The ray will bend inside the medium. And
Okay.
when the ray strikes the medium and bends in the same medium, what do you call this phenomena?
Reflection.
Reflection. So we have satisfied the second condition of total internal reflection, that angle of incidence must be greater than the critical angle. Is that clear?
Okay.
The first condition was we have to move from denser to rarer media, and the second condition must be angle of incidence must be set greater than the critical angle. Clear?
Yes.
And because we are following the process of reflection, so according to the laws of reflection, this must be the reflected ray and this must be the incident ray. So angle of incidence must be equal to the angle of reflection. Is that clear?
Yes.
Any confusion?
No.
Okay.